you woke a minute before the alarm again, and the room was still dark. There is a clock inside you, older than any bedside one. It keeps its own steady time, whether or not you ask it to. Somehow it counted the hours while you slept and woke you on time, as if a quiet part of you had kept watch all night. Welcome to Sleepy Science. For now, there is nothing to time and nowhere to be. Let your breath slow, and let that faithful inner clock keep its own count while you rest. The story of that clock begins deep inside a single cell, where the counting quietly starts. You wake, and for a moment you lie still, certain the alarm is about to sound. Then it does, right on time, as if your body had been counting the minutes in the dark. This quiet trick happens to many people, night after night. Long before scientists had a name for it, farmers and sailors noticed the very same thing. The body seems to keep its own time, even while we sleep. Underneath everything we explore tonight sits one gentle question. How does your body know the hour before you open your eyes? We will follow that question slowly, the way you might follow a single star as it drifts across a whole night sky. Imagine living deep in a cave for weeks, with no sunrise, no clock, and no way to tell morning from midnight. In the last century, a few brave volunteers did exactly that. Even cut off from daylight, their bodies still fell asleep and woke on a steady rhythm, close to an ordinary day. Their inner clock kept running on its own, like a wristwatch that never needs winding. This showed something quietly remarkable. The rhythm of sleeping and waking does not come only from the sun outside our window. Part of it is built softly into us, ticking along whether the world offers us light or leaves us in the dark. You might expect the body's clock to run exactly 24 hours, matching the turn of the earth. It comes close, but not perfectly. For most adults, the inner clock runs a little long, near 24 hours and 11 minutes when it is left completely alone. That extra sliver is shorter than the time it takes to boil an egg. Each morning, light nudges the clock back into step, the way you might reset a watch that gains a minute a day. Scientists call this near-daily rhythm circadian. Its gentle drift is one reason morning light matters so much. Your body is a clock that runs slightly slow, waiting each day for the sun to set it right. The word circadian comes from two old Latin words, circa, meaning around, and diem, meaning a day. Put together, they mean about a day. It is a fitting name for a rhythm that never lands on an exact number, only somewhere near 24 hours. Almost every living thing carries a circadian rhythm, from tall trees that lift their leaves at dawn to tiny bacteria drifting in a still pond. This inner sense of time is one of the oldest features of life on Earth. Older than eyes, older than brains. Long before any creature could see the sun, life had already learned to feel the quiet difference between day and night. For a long time, people wondered where such a clock could possibly live. It has no gears you can hold and no ticking you can hear. the search led scientists deep into the brain, to a place tucked just behind your eyes and a little above the roof of your mouth. There, inside a region called the hypothalamus, sits the body's master timekeeper. The hypothalamus is only about the size of an almond, yet it quietly manages hunger, warmth, thirst, and sleep. Hidden within it lies an even smaller structure that keeps the daily beat. Finding it took patient work, and the discovery reshaped how we understand rest, waking, and the steady rhythm of a whole life. The body's master clock has a name: the suprachiasmatic nucleus, often shortened to the SCN. The long name simply points to where it sits, just above the spot where the nerves from your two eyes cross. The SCN is astonishingly small, holding around 20,000 nerve cells in a space smaller than a grain of rice. To picture it, imagine a cluster of cells you could balance on the tip of a pencil. Yet this tiny knot of tissue sets the timing for your entire body. Each of its cells hums with a daily rhythm, and together they beat as one. Something so small, quietly keeping time for something as large as a human life. Think of an orchestra tuning up before a concert. Each musician can play alone, but without a conductor, the sound would slowly drift apart. The SCN works much like that conductor. On its own, nearly every organ in your body can keep a rough rhythm, including your heart, your liver, and even your skin. The SCN gathers all these small rhythms and waves them into time with one another. It does this with gentle chemical and electrical signals, sent out on a daily schedule. Because of this quiet coordination, your whole body tends to rise and rest together, rather than in 100 separate directions. The conductor never plays a note, yet the music would fall into confusion without it. How do we know the SCN truly runs the clock? The answer came from careful and patient animal studies. When researchers gently quieted the SCN in small animals, the tidy rhythm of sleeping and waking fell apart, scattering across the day and night. In one well-known study with hamsters, scientists moved a healthy SCN from one animal into another. The animal that received it took on the rhythm of the donor, not its own. This showed that the clock's timing lives right there, inside that tiny cluster of cells. It was a quiet but powerful lesson. The beat of your day is not spread vaguely through the body. It is kept and carried by one small and faithful timekeeper. Here is something that surprises many people the first time they hear it. If you take SCN cells out of the body and keep them alive in a dish, they keep ticking, bathed only in a warm, salty liquid, with no sunrise and no signals from the brain. These cells still rise and fall on a daily rhythm for days on end. The clock, it turns out, is not a single object resting in one place. It is built into the cells themselves, written quietly into their very chemistry. Each cell is a tiny clock, and the SCN is a room full of them, all keeping time together. The rhythm of your day begins at a scale almost too small to imagine. If a lone cell can keep time in a dish, then the clock is not really a place at all. It is a process, unfolding gently from the inside. This quietly changes the question we began with. Waking before your alarm may not be your brain reading a clock on the wall. It may be countless cells, each counting the hours in its own way. So what could a single cell possibly use to measure time? It has no hands, no numbers, and no gears. The answer lies in something smaller still, in molecules that build up and break down on a steady daily cycle. That slow rise and fall, repeated inside you right now, is the true heartbeat of the clock. Deep inside each cell sits a set of instructions we call genes, tucked into a central chamber known as the nucleus. Certain genes act like the moving parts of a clock. When one of these genes switches on, the cell reads it and builds a matching protein, a tiny working piece folded from even smaller building blocks. Proteins do much of the labor of life, and here they become the ticking of the clock. The whole rhythm rests on a simple idea, repeated over and over. A gene turns on, a protein is made, and then, in time, that same protein reaches back to quiet the gene. From this gentle loop, a full day of timing slowly takes shape. One protein sits at the very center of this daily rhythm. Its name is per, short for period, and it rises and falls like a slow tide inside the cell. Through the day, the cell steadily builds more and more PER, and the little protein gathers in greater amounts. Picture sand slipping into the bottom of an hourglass, one grain at a time. Hour by hour, the pile of PER grows taller, keeping a quiet record of how much time has passed. This build-up is not fast or dramatic. It unfolds gently, across many hours, which is part of why the whole cycle takes close to a full day to finish. Time, in a shell, is measured by patience. Before PER can rise, something has to switch its gene on. That job belongs to two partner proteins with the names clock and BMAL1. They join together like two hands meeting, then settle onto the gene and gently flip it to the on position. Once that happens, the cell begins reading the instructions and building PER, along with a helper protein called cry. You can think of clock and BMAL1 as the ones who start each day's cycle, the first movement in a long and quiet piece of music. Without them, the gene would stay silent, and the tide of PER would never begin to rise. Every daily rhythm in the cell traces back to this first, simple push. Now comes the turn that makes the whole thing a clock. As PER and its helper cry build up through the day, they slowly drift back toward the center of the cell. There, they find the very proteins that started them, clock and BMAL1, and gently switch them off. In other words, the proteins reach back and quiet the gene that made them. Production slows, and then it stops. It is a loop that feeds on itself, a circle with no loose ends. This gentle back and forth, building up and then shutting down, is the true engine of the daily clock. The cell writes a rhythm simply by making a protein that, in time, tells itself to rest. You might wonder why this loop takes close to a whole day, rather than a minute or a month. The answer lies in how slowly each step unfolds. Building the proteins takes hours. Gathering enough of them to quiet the gene takes hours more. Then they must be cleared away before the cycle can begin again. Add all these unhurried steps together, and the full circle lands near 24 hours, almost as if life had tuned it to the turning of the earth. Nothing rushes here. Each part waits its turn, like slow footsteps pacing out a day. The length of your day, felt in every cell, is simply the time this patient loop needs to complete itself once. For the clock to begin again, the old proteins must be gently taken apart. Inside the cell, small tags are attached to PER, marking it for removal. Once tagged, it is broken back down into its building blocks, and the pile that grew all day slowly disappears. With PER gone, clock and BMAL1 are free once more, and they switch the gene back on. The tide rises again, and a new cycle quietly begins. This tidy clearing away is just as important as the building up. A clock that only gathered and never emptied would soon jam. By taking itself apart each cycle, the cell stays ready to count out one more fresh and steady day. This little loop of rising and falling proteins does not run only in the brain. Nearly every cell in your body carries its own copy, quietly keeping time. From the cells in your fingertips to the ones deep within, each holds the same molecular clock, ticking through the same daily circle. Left entirely alone, these clocks would slowly drift apart from one another. That is where the SCN returns to the story. As the master conductor, it sends out steady signals that keep all these smaller clocks in step. The rhythm you feel is really a chorus of countless tiny clocks, gathered and guided into one shared and gentle beat that carries you through each passing day. This hidden machinery was not always known. For most of history, no one could say how a living thing kept its own time. The picture came together slowly, through patient study of the common fruit fly. Working over many years, 3 scientists, Jeffrey Hall, Michael Rosbash, and Michael Young, traced the genes and proteins behind the daily clock. In 2017, their work earned the Nobel Prize in Physiology or Medicine. What they uncovered in a tiny insect turned out to hold true in people too, and in nearly all living things. It is a quiet reminder that some of life's deepest patterns are shared across creatures great and small. The same gentle clock ticking inside a fly and inside you. One of the clock's gentlest gifts is that it does not simply react. It prepares. Rather than waiting for morning to arrive and then scrambling to respond, the body begins getting ready in advance. Through the night, quiet changes start to gather, so that the coming day does not catch you off guard. This is what it means to have a clock, rather than a mere alarm. An alarm only answers the present moment, while a clock can look ahead. Your body, tuned across millions of years, learned that the sun rises on a schedule, and it leans gently toward that schedule. Much of what the clock does is this soft, unseen, readying for whatever comes next. Your body temperature is not the same all day and night, though the change is small enough that you rarely notice it. It follows the clock in a smooth, daily wave. In the late afternoon and early evening, your inner temperature sits at its highest point. In the small hours before dawn, it drifts to its lowest, often about 2 degrees Fahrenheit cooler. That may sound tiny, yet it is one of the clearest signs of the clock at work. This cooling in the depth of night is part of what helps you sleep, and the gentle warming toward evening is part of what keeps you alert. A quiet tide of warmth, rising and falling, marks the hours inside you. As evening deepens and the light fades, your body begins releasing a hormone called melatonin, often nicknamed the hormone of darkness. Melatonin does not force sleep so much as whisper that night has come. Its levels stay low through the bright hours of the day, then rise quietly a couple of hours before your usual bedtime. This slow rise is like a soft signal passing through the body, telling countless cells that rest is drawing near. Melatonin is not a sleeping pill made by nature. It is more of a messenger, gently marking the time. When it rises on schedule, night after night, it helps hold your sleep in its proper place along the turning of the day. Melatonin does not decide on its own when to appear. It takes its cues from the master clock. Deep in the brain sits a small structure called the pineal gland, once thought mysterious by ancient scholars. The SCN sends signals to this little gland, telling it when darkness has fallen and when to release melatonin. In this way, the clock reaches out and gently shapes the chemistry of your night. When bright light reaches your eyes in the evening, the SCN holds melatonin back, which is one reason glowing screens can delay sleep. The timekeeper and the messenger work hand in hand, one counting the hours, the other carrying the news of night through the body. The inner clock is steady enough that it can keep running even when the outside world falls silent. Some people who cannot see any light at all still carry a daily rhythm, their bodies rising and resting close to an ordinary day. In steady dim light or constant dark, the clock does not vanish. It simply free runs on its own near-daily beat. This quiet reliability is part of what makes it a true clock, rather than a passing mood. It does not depend on any single day's weather or light to survive. Built into the body across countless generations, it holds its rhythm gently but firmly, a timekeeper that rarely stops to rest. Consider how precise this quiet clock really is. Left entirely alone, it drifts by only a handful of minutes each day, a smaller error than many old wristwatches once made. Over a single night, that drift is so slight it can pass completely unnoticed. This is why your body can guess the hour with such gentle accuracy. and why you so often stir just before the alarm. Your cells have been counting all night, each ticking within a few minutes of the last. There is something calming in that thought. While your mind rested and your worries fell quiet, a faithful timekeeper stayed awake inside you, marking the hours softly, never once losing its place in the dark. So we return to where we began, to that small moment of waking just before the alarm. It no longer seems like chance. Across 25 quiet steps, a picture has taken shape, a master clock in the brain, a chorus of clocks in every cell, and a slow loop of proteins rising and falling to mark a day. The question has gently turned. We asked how your body knows the hour, and we find that it does not so much read time as make it, from the inside. Yet one thread still hangs loose. Knowing the hour is one thing, but preparing you to wake, minute by minute, is another. What readies the body for morning is where the next part of our night begins. The hours we've followed so far have moved slowly, like a clock winding down, and more waits gently ahead. A quiet subscribe helps another restless mind find this calm too. Now, let's breathe here together, one sleepy soul at a time. Somewhere in the small hours, your body cools by a degree or two, all on its own. You did not ask it to. It follows the count it has kept since you were born. Right now, behind your closed eyes, that tiny cluster of cells is still ticking, gathering and releasing, the way it has all day. You don't have to feel it working. It needs nothing from you. There is a quiet comfort in knowing that something inside you keeps such faithful time, even as your thoughts grow slow and loose. Let your breathing lengthen. Notice how little effort rest asks of you. The clock has already begun to lean toward morning, softly readying what comes next, and the hours ahead follow that gentle turn. Long before your eyes open, your body has already started getting ready. Waking is not a switch that flips in an instant. It is more like a slow sunrise happening inside you, beginning while you are still deep in sleep. Over the final hour or so of the night, a quiet sequence begins. Hormones shift. Your temperature edges upward. Your heart takes on a gentler, quicker pace. None of this asks for your attention, and you sleep right through it. By the time you actually stir, most of the preparation is already done. Your body, it seems, likes to arrive a little early. One of the first signals to move is a hormone called cortisol. People often call it a stress hormone, but that name is a little unfair. Cortisol is really more of a get-ready hormone. In the last few hours before you wake, its level begins to climb, steadily and quietly. Think of a heater on a timer, warming the house before anyone gets out of bed. Cortisol does something similar for your body. It nudges your blood sugar up and helps rouse your systems for the day. The rise starts long before the alarm, while the room is still dark and you are still dreaming. The climb does not stop when you open your eyes. In the first 30 to 45 minutes after waking, cortisol rises again, often by about half as much as it already was. Scientists call this the cortisol awakening response. It is one of the more dependable patterns in the human body, showing up morning after morning in almost everyone. Picture two gentle pushes. One lifts you toward the surface of sleep. A second, smaller one arrives just after you reach it. Together they help explain why those first minutes awake can feel foggy at first, and then slowly clearer. Your body temperature follows its own quiet schedule through the night. It drifts down to its lowest point in the early morning hours, usually a couple of hours before you normally wake. Then, without any effort from you, it begins to rise again. This small climb is part of getting your body ready for movement. Think of an oven preheating before the food goes in. A warmer body is a body prepared to be active. By the time you sit up, your inner thermostat has already turned itself back toward day, matching the rhythm it follows every single night. Your heart and blood vessels take part in this early preparation too. In the hours just before waking, heart rate and blood pressure begin a slow, steady rise. Doctors sometimes call this the morning surge. It is the body's way of getting ready to stand up and move against gravity. Imagine a car warming its engine on a cold morning before the drive. Your circulation does something similar, easing itself from the deep calm of sleep toward the demands of the day. This happens on its own timing, tied to your internal clock, and not to the sound of any alarm. Here is where things become genuinely curious. In one careful study, researchers told a group of sleepers they would be woken at 6 in the morning. Another group was told 9. The people expecting the early wake showed a rise in stress hormones in the hour or so before it, long before any alarm sounded. The late group showed no such early rise. Nobody was woken by a clock. The bodies simply prepared for the hour they were expecting. It was as if some quiet part of the mind had been keeping track through the night, counting down toward a moment it had been told about in advance. Sit with what that experiment suggests. Your body did not just respond to morning light or to noise. It seems to have responded to an expectation, set the evening before. Somewhere beneath awareness, a kind of timing was running, matching itself to the hour you had in mind. The question we started with is beginning to turn. Waking early may not be luck, and it may not be a lucky guess. It may be your body quietly rehearsing the hour you asked of it, long before that hour arrives. What we are watching is not a clock that rings. It is a body that prepares, and it prepares for you. Part of this readiness comes from a shift in your nervous system. Through the deep hours of night, the calming, restful side is in charge, slowing you down. As morning approaches, the more alert side begins to take a gentle lead. Small amounts of adrenaline and related signals start to flow. This is not the sharp jolt of fear. It is a soft handover, like one shift of workers quietly relieving another. You feel none of it directly. Yet by the time you wake, the balance inside you has already tipped, just slightly, from deep rest toward the readiness that a new day asks for. While all this rises, another signal quietly steps back. Melatonin, the hormone that helps carry you into sleep, stays high through the middle of the night. In the hours before dawn, its level begins to fall. As melatonin fades, the door to wakefulness opens a little wider. Think of it as a dimmer switch slowly being turned, letting a soft light back into the room. You do not decide when this happens. Your internal timing does it for you, releasing you gradually rather than all at once. By early morning, the hormone that guarded your sleep has mostly withdrawn for the day. The shape of your sleep changes toward morning as well. Early in the night, you spend more time in deep, heavy sleep. As the hours pass, those deep stages grow shorter, and lighter sleep and dreaming fill more of the time. By the final stretch, before waking, much of your sleep is light. This is part of why waking near your usual hour can feel smooth rather than jarring. You are already resting close to the surface. Picture a swimmer drifting slowly up from the deep, so that breaking through feels gentle. Your night is arranged to leave you near that surface at the right time. Now, the small mystery starts to make sense. When you wake a few minutes before the alarm, you are not being lucky. Your body has spent the last hour climbing gently toward this moment. Cortisol has risen. Temperature has lifted. Sleep has grown light. And the whole system has aimed itself at your expected wake time. The alarm is simply late to a party your body has already prepared. That soft feeling of waking on your own, just ahead of the buzzer, is the sound of good timing. It is not chance. It is a rehearsal, quietly kept, arriving right on schedule. Compare that to the mornings when the alarm drags you out of deep sleep. If the sound arrives while you are still in a heavy stage, you wake with a thick, groggy feeling. Scientists call this sleep inertia. It can last a few minutes or a good deal longer, leaving you slow and cloudy. The difference is timing. Waking on your own, near the surface, feels clear. Being pulled up from the depths feels rough. It is a bit like being gently nudged awake versus being tugged upright too soon. Your body, given the chance, prefers to choose the softer of those two moments. The more regular your mornings, the sharper this timing becomes. A body that wakes near the same hour each day learns to expect it. The rise of cortisol, the lift in temperature, and the lightening of sleep all begin to line up more precisely around that hour. Think of a musician who plays the same piece each day until the fingers know it without thought. Your inner timing rehearses your wake moment in much the same way. Consistency is what turns a rough guess into something close to precise. Keep your mornings steady, and your body grows quietly better at meeting them. You may have noticed this on a free morning. Even with no alarm set, on a lazy weekend, you often stir near your usual time. Your body has been practicing that hour all week, and it does not forget overnight. The same thing can happen with a short afternoon nap, where you wake before anything wakes you. This is the internal timing carrying on, whether or not you have given it a task. It runs in the background, faithful and steady. Some quiet part of you is always keeping the hour, even on the days you had hoped to sleep straight through it. Step back, and the whole picture holds a quiet kind of wonder. Every night, without a single instruction from you, your body sets a plan and follows it. Hormones rise on cue. Warmth returns. Sleep thins toward the surface. All of it aims at a single moment you chose, sometimes to within a few minutes. There is a kind of care in that precision, a body working through the dark on your behalf. You do not have to manage any of it. You only have to rest and trust that the timing you cannot feel is already, gently, keeping watch over your morning. Something in you has been keeping time all along, without needing to be asked. Let your breath slow, and let that be enough. There is nothing here for you to manage. The same quiet care that lifts you toward morning is with you now, in the dark, needing nothing from you at all. Notice how steady it is, how little it asks. Let's drift on together, slowly. Your brain is not the only place that keeps time. Almost every organ in your body runs its own small clock. Your liver, your heart, your kidneys, even the lining of your gut. Each one tracks the hours on its own. Scientists call these peripheral clocks, meaning clocks out at the edges, far from the brain. They are built from the same looping proteins, the PER molecules, that tick inside your master clock. Picture a large company where every department keeps its own schedule, yet all of them follow the same workday. Your body is a company of trillions of cells, and nearly every one of them knows roughly what time it is. Consider your liver, one of the busiest organs you own. It does not wait for food to arrive before getting ready. Its clock slowly learns your eating pattern, then prepares digestive enzymes and stores sugar in advance. So a meal meets a kitchen already warmed up. Around the times you usually eat, the liver quietly shifts gears on its own. This is why food at your normal hour feels easy, while a meal at a strange hour can sit heavy. The liver behaves like a cook who knows exactly when dinner is served, and starts chopping long before the guests walk through the door. Your heart keeps time as well, and it uses that timing to prepare you for the day. In the last hours of sleep, its clock helps blood pressure rise slowly, like a thermostat nudging the heat up before you wake. Your resting heart rate follows a daily curve too, dipping low at night and lifting gently toward morning. None of this needs a single thought from you. The heart simply reads its own clock and the signals arriving from the brain, then adjusts. It is a quiet rehearsal, happening in the dark, so that rising in the morning never catches your body by surprise. Deep in your gut, another clock is ticking. The muscles that move food along, the cells that soak up nutrients, even the trillions of bacteria living inside you. All of them rise and fall with the day. Your digestion runs faster and smoother during your normal waking hours. At night, the whole system slows down to rest, much like a shop lowering its shutters after closing time. The bacteria shift too, some more active by day, others by night. Your gut is not a simple tube. It is a living neighborhood that keeps its own hours, right alongside the rest of you. So how do all these separate clocks stay in step, the master clock in your brain? The SCN keeps them aligned. It works like the conductor of an orchestra. Each organ is a musician who can play alone, yet the conductor keeps them from drifting apart. The SCN sends out steady signals through nerves and through hormones carried in the blood that gently correct each clock. Without a conductor, the players would slowly fall out of rhythm. With one, trillions of cells still manage to agree, hour after hour, on what time it is. The signals it sends are the quiet thread tying the whole body to a single hour. Even a conductor needs a way to set the correct time. For your body, that master signal is light. Near the back of each eye sit special cells that do not help you see at all. Instead, they simply measure brightness and send that reading straight to the SCN. Scientists call the daily signals that set our clocks Zeitgebers, a German word meaning time givers. Light is the strongest Zeitgeber of them all. Like a radio tower broadcasting the official time, the sky tells your brain whether it is morning or evening, and your clock listens closely to every word it hears. Here is a small puzzle. Your internal clock does not run at exactly 24 hours. Left completely alone, it runs a little long, closer to 24 hours and 11 minutes. So why don't you slip later and later each day? Morning light is the reset. When bright light reaches your eyes after waking, it nudges the clock back into line, the way you tap a watch that runs slightly slow, which means your clock was never sealed away inside you. It has been listening to the world the whole time, asking the sky each morning what the true hour really is. Not all light speaks to your clock equally. The cells at the back of your eye respond most strongly to blue light, the kind that fills the sky in early morning. Dawn is naturally rich in these blue tones, which makes sunrise the clearest signal your body can receive. A few minutes of morning sky can carry more timing information than hours of dim indoor light. Even on a cloudy day, the outdoor light is far brighter than most rooms. Your clock grew up under an open sky, and it still leans toward that wide, blue morning light, the way a plant leans toward a window. Light is not the only time giver you have. When you eat can set your clocks too, especially the ones out in your organs. Your liver, in particular, pays close attention to meal times. If light says one thing and food says another, those peripheral clocks will often follow the food. It makes sense. For most of history, eating meant daytime and activity. So, a regular breakfast quietly tells your body that the day has begun, almost like a second sunrise felt from the inside. The sky sets the conductor, while your meals help set the players seated further away from the brain. When your two main signals agree, something graceful happens. Morning light and a morning meal point in the same direction, and your clocks lock together like singers finding one shared note. The brain, the liver, the heart, the gut, all of them read the same hour. Your body moves as a single, well-timed whole. This is the quiet order that a steady daily rhythm builds, day after gentle day. And it opens a soft question for what comes next. What happens on the days when these signals disagree? When the sky outside and the clock within no longer tell the same time? You just heard how a single shared note can pull a whole body into agreement. The brain, the liver, the heart, all reading the same quiet hour. That agreement is not something you arrange. Even now, in the dark, your own clocks are finding one another. The way instruments settle into tune before the music starts. There is something steadying in that. All day you decide, and plan, and correct. Underneath all of it, an older order keeps working, asking nothing from you at all. Notice how little effort your breathing takes. It carries a rhythm too, one you were never in charge of. What comes later follows the days when that inner agreement is tested. But not now. For this one moment, let every part of you drift into the same slow time. Cross 3 or 4 time zones on a plane, and something curious happens. Your body keeps the time of the place you left behind. The clock inside you does not know the plane has landed. It still expects breakfast, sleep, and daylight on the old schedule. This mismatch is what we call jet lag. Your inner clock and the new sun are simply telling different times. For a few days, you live in 2 time zones at once, one shown on the wall around you, and one you quietly carry within. Flying east tends to feel harder than flying west, and there is a gentle reason why. Your inner clock naturally runs a little longer than 24 hours. That means stretching your day later, as you do flying west, comes fairly easily. Flying east asks the opposite of you. It asks your clock to begin the day sooner than it wants to. Shortening your internal day is the harder task. It is a bit like being told to fall asleep an hour early. Your body resists at first, then slowly, over several nights, it agrees. Your clock does not leap to a new time zone overnight. It shifts slowly, at roughly 1 hour each day. So after a flight across 6 time zones, your body may need around 6 days to fully arrive. This is why travelers feel foggy in the morning and wide awake near midnight. The clock is turning its hands one small step at a time. There is no switch to flip and be done. Like a large ship changing course, it moves in a wide, patient arc rather than a single, sharp turn. Jet lag is quiet proof of something worth noticing. If your body simply followed the sun Landing somewhere new would fix everything at once. Step into morning light, and you would feel like morning. But that is not what happens. The tiredness lingers for days, because the clock lives inside you, not out in the world. It carries its own sense of time, stubborn and self-made. The sun can nudge it, yet cannot force it. What you feel as jet lag is really your inner clock, patiently holding its ground. Morning light is the gentlest tool for easing jet lag. When you arrive somewhere new, stepping into daylight helps your clock find the local time. Light reaches special sensors in your eyes and sends a quiet signal inward to the brain. That signal says, "This is now morning here." Over several days, the clock listens and slowly turns to match. Bright morning light after traveling east can help draw the clock a little earlier. It is less a cure and more a conversation. Your body and the new sun, slowly agreeing on when the day begins. Some people work through the night while the world sleeps. Nurses, drivers, bakers. Their bodies face a quiet struggle. The inner clock still expects sleep in the dark hours, whatever the schedule may ask. Working at 3 in the morning means moving against a tide that wants to pull you under. The clock has spent a lifetime learning that night means rest. Asking it to reverse is a little like asking a river to flow uphill. Even with coffee and bright lights, part of the body keeps insisting it should be asleep. You might expect that years of night work would retrain the clock completely. Surprisingly, it rarely does. For most night workers, the inner clock never fully turns around, even after a long time. On days off, the body drifts straight back towards sleeping at night. The clock treats daytime sleep as a temporary detour, not a new home. It seems the pull of the sun, felt across a whole life, runs deep. This is why night shifts can stay tiring for years. The body is quietly commuting between two schedules that never quite meet. Here is a subtle piece of the puzzle. You do not carry just one clock. You carry many. Your liver, your stomach, and your heart each keep their own time. Normally, the master clock in the brain holds them all in step, like a conductor leading an orchestra. But shift work and jet lag can pull them apart. The brain may shift toward a new schedule while the liver lags behind. For a while, your organs are playing different hours. Scientists call this internal desynchrony, an orchestra where the sections have lost the shared beat. Because those inner clocks fall out of step, shift work can feel like jet lag that never ends. A traveler recovers after a few days in one place. A night worker keeps switching between work nights and ordinary days, week after week. The clocks never get the steady signal they need to settle. So the foggy, out-of-place feeling can linger far longer than any single flight. It is not weakness, and it is not poor habit. It is simply a body built for daylight, gently asked to live against its own quiet rhythm. Light is the strongest signal your clock listens to, and it does not only matter outdoors. A bright room late at night speaks to your brain in the language of daytime. To the clock, light means the sun, and the sun means stay awake. So an evening spent under bright bulbs can quietly tell your body that the day has not yet passed. The message is simple and very old. Light is day. Dark is night. Your clock has trusted that rule for millions of years, long before lamps and screens ever existed. Not all light speaks to the clock equally. Blue light, the kind found in daylight and in many screens, carries the loudest message. Your eyes hold special sensors that mainly listen for this blue wavelength. These sensors do not help you see shapes or colors. Their only task is to tell the brain whether it is day or night. When blue light reaches them in the evening, they send a daytime signal at the wrong hour. It is as if a small part of your eye keeps watch for the sun, faithfully reporting back. As night falls, your brain releases melatonin, a hormone that whispers, "It is time to rest." This gentle wave usually begins a couple of hours before sleep. But bright light in the evening can hold that wave back. A phone or television close to your face, glowing with blue light, tells the brain the day is not yet done. So melatonin arrives late, and sleepiness arrives late along with it. The hormone is still willing to come. It is simply waiting for the light to soften before it quietly begins. Evening light does more than delay a single night's sleep. Night after night, it can nudge the whole clock later. Bright light in the hours before bed pushes your internal day backward. So sleep and waking drift toward later times. Morning light does the opposite, drawing the clock earlier. Your body is always reading the balance between the two. This is why someone bathed in screen light each night may slowly become a later and later sleeper. The clock is not broken at all. It is simply following the light it is given. There is a quiet kindness you can offer your clock in the evening. Softer, warmer, dimmer light carries a weaker daytime signal. As rooms grow dim and golden near bedtime, the brain reads the fading glow as dusk. Melatonin is allowed to rise on time, and sleep feels a little closer. For most of human history, evening light was exactly this: the low flicker of fire, the last color left in the sky. Your clock still recognizes that ancient signal. When the light softens, something in you understands the day is letting go. Light is not the only thing that sets your clocks. Food is a signal too. The clock in your liver pays close attention to when you eat, more even than to the sky outside. Eat at an unusual hour, and the liver begins to shift its own time toward the meal. In this way, food can pull the body's inner clocks in a direction light alone never would. And here the little mystery of waking before your alarm quietly turns. Perhaps such precision is not one clock ticking, but many clocks, held in careful agreement with each other. When you eat late at night, an interesting split can appear. Your brain, reading the darkness, is preparing for sleep. Your liver, reading the meal, believes the active day has returned. The two clocks briefly disagree. The brain says night, the liver says morning. Eating often in the small hours can keep them out of step, much like the desync of jet lag, but caused by the dinner table instead of a plane. The body handles a single clock with ease. It is the quiet argument between clocks that leaves it feeling unsettled. The same meal can meet a different body depending on the hour. Your metabolism, the way your body handles food and energy, rises and falls on a daily rhythm. In the morning, the body is often primed to use food well. Late at night, those same organs are winding down and less ready. So, identical plates, eaten 12 hours apart, are not quite equal to the body inside. It is a little like watering a garden. The same water does more at dawn than under the midnight dark. When everything is resting, even your gut keeps time. The lining of your intestines follows a daily rhythm, busiest during your usual waking hours. It prepares for food when food normally arrives, like a kitchen that opens just before the regular breakfast crowd. When meals come at their expected times, the gut is ready and calm. When they arrive at odd hours, it must hurry to catch up. Deep inside you, in a place you never think about, a small clock is quietly guessing when the next meal will come. And usually, it guesses right. Weekends can gently confuse the clock. Through the week, you may wake early for work under an alarm. On Saturday, you sleep in, staying under the covers into the late morning. To your inner clock, this shift feels a little like flying west into a new time zone. Scientists have a soft name for it: social jet lag. You never left home, yet your clock has drifted an hour or two later. The change is small, but the body still notices the difference between the weekday sun and the weekend one. This is part of why Monday morning can feel so heavy. Over the weekend, the clock drifted a little later than usual. Then the alarm returns, asking the body to wake at the old early hour again. For a morning or two, you feel a faint version of jet lag. Tired at the start, more awake by night. No plane was ever involved. Only the quiet gap between the late weekend clock and the early weekday one. Your body is simply catching up with a small journey it took while sitting perfectly still. Notice a quiet pattern running through all of this. The clock is steadiest when its signals arrive at familiar times. Light, meals, and sleep at regular hours let the many inner clocks stay in step with one another. When those signals wander, the clocks drift apart, and the body feels the small strain of catching up. It is a bit like a choir singing together. Easy when everyone holds the same beat. Harder when the timing scatters. The body does not ask for perfection. It simply leans, softly, toward whatever is steady. Now consider how precise this inner clock truly is. Place a person in a room with no windows, no clocks, and no hint of the sun, and their body still keeps time. Sleep and waking keep cycling on a steady beat, close to 24 hours. The rhythm does not scatter or fade. Cut off from every outside signal, the clock keeps counting on its own. This tells us the timing was never borrowed from the sky above. It was built inside, a faithful rhythm running quietly in the dark. That steady rhythm is kept by a tiny cluster of cells in the brain. Each cell in this cluster can keep time on its own, like thousands of small metronomes. Alone, a single cell keeps only rough time. Together, they listen to one another and fall into remarkable agreement. From that shared beat comes a rhythm accurate to within minutes across a whole day. It is one of the quietest wonders of the body, a crowd of tiny timekeepers, each one imperfect, becoming precise only by keeping time together. Your clock does more than count the hours behind you. It also looks ahead. In the last stretch of sleep, before any alarm sounds, the body begins to prepare for morning. Certain hormones rise, warmth returns, and the mind drifts gently toward the surface. The clock is not reacting to the dawn. It is expecting it. Having learned the rhythm of your days, it readies you for a sunrise it can feel approaching. This is a clock that does not merely follow time. It quietly predicts it and prepares you before the day arrives. And so the small mystery finds its answer. You wake moments before the alarm because your body has been keeping time all along and learned to expect the morning. Deep in your cells, certain proteins rise and fall in a loop that takes close to a day to complete. A molecular rhythm that builds, then quietly clears, then builds again. This tiny cycle, repeating in millions of cells, is the clock itself. The sun only fine-tunes it. The timekeeping was yours from the very start, precise enough to greet the dawn before it comes. The loop you just heard about is turning inside you right now. Proteins rising and falling within your cells, building through the day, clearing through the night, without a single instruction from you. You have never once had to wind this clock. It has kept your time since before you can remember, counting quietly while you worked, while you worried, while you slept and never knew. There is something to rest in here. The part of you that keeps such careful time asks nothing of your effort tonight. It will greet the morning whether or not you tend it. Let your hold on the hours loosen. The counting will go on without you. What all of this has been circling is close now. There is a gift you can give the clock inside you, and it costs nothing. Wake at a similar time each morning, even on the quiet days when nothing is asking for you. Your inner clock loves a steady signal more than a perfect one. When the hour you rise stays close from day to day, the whole system settles. The way a room grows calm when one soft lamp is always left on. Light is the language your clock understands best. In the first hour after waking, step toward a window or into the early day, and let the brightness reach your eyes. Morning light tells the small timer in your brain that the day has truly begun. That single message lines up everything that follows. When you feel awake, when you grow tired, when sleep will find you again tonight. Deep in your brain sits a cluster of cells no larger than a grain of rice, and it has been keeping time for you all your life. Scientists call it the master clock, but you might think of it as a quiet conductor. It never asks for thanks. Through every busy day and every restless night, it holds the beat, waiting patiently to guide you back toward rest. As the day fades, your clock listens for softness. Dimming the lights an hour before bed is like lowering your voice in a sleeping house. Bright screens and harsh lamps whisper morning to a brain that is ready for night. When you let the evening grow gentle and golden, you are simply agreeing with the clock, telling it, yes, the day is done, and rest may come. When darkness settles, your body begins to make a gentle chemical called melatonin. It is not a sleeping pill your body swallows. It is more like a soft announcement that night has arrived. Melatonin rises quietly in the evening and fades again near dawn. You do not have to feel it working. It moves through you like dusk moving across a field, unhurried, asking nothing, only letting the light go. Your clock keeps more than one kind of time. Beyond light, it quietly notices when you eat. Regular meals, spaced across the day, become small landmarks the body learns to expect. Late-night eating can confuse this gentle rhythm, the way a knock at midnight startles a quiet home. There is nothing to fix tonight. Simply knowing that mealtime speaks to your clock is enough to let the thought soften. Something quiet happens to your warmth each night. A little before sleep, your inner temperature begins to fall, dropping by only a degree or so. This gentle cooling is one of the clock's oldest signals for rest. It is why a warm bath before bed can help, as your skin releases the heat. Your core cools, and the body reads that softening as an invitation to sleep. Mornings can feel like a slow tide coming in, and there is a reason for that. In the last hours before you wake, your body lifts a little cortisol, a signal that gently readies you for the day. This is the same quiet preparation that lets you stir just before the alarm. Tonight, that rise is still far away. For now, your body is doing the opposite, letting everything lower, letting everything rest. You do not need a flawless routine to keep your clock happy. It asks only for something close to steady. Going to bed and rising within a similar window most days does more good than any single perfect night. Even weekends, kept roughly in rhythm, let the clock rest instead of resetting. Think of it as a friendship. It grows not through grand gestures, but through showing up gently, again and again. You are not carrying one clock, but many. Your heart, your liver, your skin. Nearly every organ keeps its own quiet timing. The master clock in your brain is simply the conductor, helping them all play in tune. When you live in a steady rhythm, these small clocks fall into harmony, like instruments settling into one slow song. Right now, in the dark, that song is quietly turning toward its softest notes. Inside your cells, a tiny protein called PER rises and falls across each day. Through the daylight hours, it slowly builds. Through the night, it quietly breaks down. This slow climb and fall is the heartbeat of your clock, a loop that takes almost exactly 1 day to complete. You cannot feel it, yet it is happening in you now. A small tide inside every cell, keeping perfect, patient time. The gentle rhythm of that protein is close to 24 hours, but not exactly. Each morning, the light quietly nudges it back into place, the way you might tap a swing to keep it moving smoothly. This is why your clock never drifts far. Day by day, it is corrected by the sunrise, held steady by something as simple and faithful as morning arriving on time. Your clock has learned you over the years. It knows the hour you usually rise, the moment you tend to tire, the rhythm of your ordinary days. This is why, on a morning you plan to rise early, your body sometimes readies itself before the alarm ever sounds. It has been counting quietly through the night, keeping its promise to have you ready, gently, right on time. There is something quietly moving about all of this. Without a single thought from you, your body has been measuring time since before you were born. It counts the hours while you work, while you worry, while you sleep. You have never once had to remind it. Tonight, you can let that be a comfort. Somewhere inside you, a faithful timekeeper is watching over the night. We began by wondering why you so often wake a few minutes before the alarm. By now, the answer has quietly changed shape. It was never nerves, never luck. Your clock simply knew the hour was near and lifted you gently on its own. What once felt like a small mystery turns out to be a kind of care. Your body waking you before anything ever had to. So you can rest a little easier now, knowing what watches over your nights. The conductor inside you never sleeps in the way you do. It softens your temperature, releases the evening's melatonin, and counts steadily toward morning. You do not have to manage any of it. All that is asked of you tonight is to lie still and let the quiet keeper do what it has always done. This gentle timekeeping is not yours alone. Flowers open and close to it. Birds know when to sing. Even the smallest living things carry a version of the same quiet clock. For billions of years, life on Earth has turned with the day and the night. When you settle into your own rhythm tonight, you are joining something very old. The slow, shared breathing of a whole living world. Notice how the night asks nothing of you. The clock does not need your effort, only your willingness to let go. Somewhere in your cells, the small protein is drifting downward, the way it does every night. Your warmth is lowering. Your breath is slowing. Everything is moving in the same gentle direction, toward rest, and you are simply allowed to follow it. For all the hours you spend watching clocks, tonight you can set that watching down. The one inside you keeps far better time than any face on a wall. It will hold the hours while you drift. It will carry you gently to morning. There is nothing left to track, nothing to count. You can let the whole idea of time slip softly out of your hands. When morning comes, it will find you the way it always has. Light will reach your eyes. The small timer in your brain will stir. Cortisol will rise like a slow sunrise of its own, and your body will lift you gently into the day. But that is hours away. For now, there is only the dark, the quiet, and the steady clock keeping watch. How quietly you have been cared for, all this time, without ever noticing. All your life, this rhythm has risen and fallen inside you, faithful as the tide. It asked for nothing. It simply kept its promise, night after night. Tonight is only one more turn of that gentle wheel, and it is already carrying you softly towards sleep, the way it has every night before. You can trust your body now, the way you might trust the ground to hold you. It knows the hour. It knows the way to rest. There is nothing to figure out, nothing left to decide. Let the small clock inside you take the lead. It has never once lost its way in the dark, and it will not lose the way tonight. Feel how heavy and warm you have become. This is the clock's oldest gift, the slow slide into rest that comes to every living thing when night falls. You do not have to reach for it. It is already here, moving through you, softening the edges of the day. Let yourself grow heavier still. The rhythm has you now, and it is gentle. Somewhere inside you, a tiny protein is finishing its slow fall toward night. It has done this every day of your life, and it will do it again tomorrow, without your asking. This is the quiet miracle you were born already knowing. You do not have to understand it to be held by it. Simply let it carry you, the way it always has, down into the soft, dark. You have never once been late to your own life. Through every night you can remember and every night you cannot, something inside you kept perfect time and never let you go. You wake before the alarm because you were always being cared for. Gently, exactly. Tonight, you can finally rest inside that knowing. You are held. You are on time. You are, and have always been, right where you belong. 100 facts ago, waking before the alarm felt like a small, private mystery. Now it has a name and a shape, a clock the size of a grain of rice, counting quietly through the dark. We followed the protein called PER as it rose with the day and fell with the night. We watched cortisol lift in the last hours before dawn, readying you before you ever stirred. What began as a puzzle became something gentler, proof that your body has been keeping faithful time all along. Your clock was never something you had to wind or watch. It has simply loved you in the language of time, steady, precise, and endlessly patient. Tonight, you can let it hold you. If these quiet facts about the clock inside you brought a little wonder and a little calm, you might leave a gentle like or a soft subscribe. It helps another restless mind find this steady place in the dark. One quiet tap, one peaceful night at a time. Right now, in the quiet of your cells, the small protein of your clock is settling toward its lowest point. Not because you asked, because the day is done, and the night has its own slow chemistry. All through you, the many clocks are falling into one soft rhythm. Heart, breath, warmth, all turning gently toward rest. Let your whole self dissolve into that rhythm. You do not have to keep the time. It is already keeping you. You can let these thoughts fade now, the way the evening's light slips away without struggle, dimming into a softer, dark. Let your body grow heavy and still. If sleep comes, let it carry you toward morning, where your body will lift you gently, right on time, the way it always has. The Sleepy Science playlist has spent many quiet hours in this territory, the place where the body's hidden rhythms meet the calm of the dark. The next hour follows the part of tonight's question this one didn't have time to finish. That hour is waiting whenever you are ready. But if your eyes are closed, stay there. Rest well. Quiet 1. Your clock is keeping perfect time, so you don't have to. Where science becomes the softest place to rest. Good night.